transistor switch, essentially, and it detects phototransistor light, or infrared light. And it switches open when it detects infrared light, which is the 950 nanometer wavelength. And then I programmed the Arduino to actually take in the infrared signal from my Apple remote. Right, my Apple remote, and then actually decode it into its binary representation of the data that's on the stream, on the wavelength on the stream. So there's two parts I wanted to show. I showed this to John the other day, and he thought it was kind of cool how I set up the scope to trigger on the waveform so I could read it, and then I wanted to show the program. So on the oscilloscope, I just set I set it up so that it would you can see it about 3 volts, and then I also set the trigger on the rising edge, because whenever it detects the signal, it's going to go from 0 volts all the way up to 3.3 volts, ideally. And so when I do that, if you're looking at the scope, what you see is just a bunch of looks like pulse width modulation. And so if I hold it, you just get this one little thing. And so the problem I had was I wanted to look at all these cool ones, the part that had all the different bits in it, instead of just this. This right here is called the repeat character, which is just when you hold the button, you get this character. And so I found out that if you click on a single button on the scope, it'll actually detect. It'll just grab one piece. The first time the trigger gets activated, it just grabs just the data from that one trigger and then displays it. So from here, you can actually, I was actually able to view the entire waveform. So, any questions? That's about it.
It's pretty cool.
For this part. Question?
Were you able to actually discern from up, down, left, right?
Yes.
Play? I don't know what buttons you have. So it looks like
So it has up, down, left. It has volume up, down, play, menu, and then the track left and right. So 6 buttons. And I can show you the binary of what's different between each of those commands in the next part.
Okay.
Any other questions about the cool waveform?
What's the resolution on that?
On the
on the incoming stream?
On the scope?
Yeah, I mean, is it like an 8-bit or is it 16?
How wide are the pulses?
Yeah.
How wide are the pulses?
Yeah,
well, it's kind of like a pulse width modulation, so it's timed. It's either it's on or off, and the Apple remote, it has a certain protocol standard that it follows on how to read the data, and so it goes. So usually, so it'll pulse for about like 56 microseconds or 560 microseconds, and then it'll be off for 560 microseconds to indicate that it's 0, or it'll pulse on for 650. It'll pulse on and then pulse off for about 3 times that. Okay. So it's like you're looking at timing for whether you're decoding a 1 or a 0 between pulses. Any other questions?
So the things that, like when you click a button on a remote, every remote has a standard, you said? And
yeah.
How did you find those standards? Did you look them up, or?
Yeah, I found a website called www.sdprojects.com, and it had a knowledge base on infrared stuff, TV remote, infrared codes and stuff, and it had a whole page of like 7 or 8 different encoding mechanisms that different TV manufacturers have used over the years. The one that the Apple used was called NEC, but like Sony has its own protocol, Panasonic has its own, and so it's just there's a lot of different kinds.
Cool. So then when you have a universal remote, I remember you telling me about that, like how that works. How does a universal remote adjust to many different TVs?
Well, universal remotes have a microcontroller in them, essentially, so all the buttons are tied to it, and then depending on Because usually when you have a remote, you program it with your three button code of what remote you have, and that goes to a lookup table in the controller to indicate whether or not it's to indicate what protocol it is, and then it just, when you press the button, it just goes through that protocol. All right, so now we wrote a program to read the infrared data and be able to interpret it. So I've programmed the Arduino to take that input stream and then send the data bits over the serial port to the, so you can look at it, essentially. So, turn on the serial monitor, and so when I push the play button, this is what happens. We receive the data bits from the controller. So when I push the button, you get a new line. And if you hold the button, it keeps sending it a repeat character to let you know, to tell you that it's still holding the button. And that's it.